Okay, so just a recap, every triangle can be classified based on side length and based on angles. But we also know that there's a relationship between side lengths and angles, right? So for example, you're supposed to qualify or classify based on side length. I can look at my angles and they will give it away as well. They will tell me if all sides are the same length. So sometimes, even though we're classifying by side length, you still look at the angles, right, to help you there. And so acute, obtuse, right is for angles, and equilateral isosceles, scalene. You should probably have that on your study sheet because you will forget. You'll forget that one name, and they all supposed to have both of them present, okay? So let's do the math. I started yesterday and then I told you not that we weren't going to do it that way. So use the following diagram to answer the question. So we're here, and here I want you to zoom out a little bit. That's why I do trig before I do this. I don't know if you recognize, but this triangle right here, if we were to draw it out without the partition in the middle, you're being told that this side length is the same thing as this side length, right? So actually, if by them giving you 20 here, they're also telling you that this is 20. Okay? You know that if this is 53 and 53 is across the 20 here, you are also guaranteed that this is 53 here. I'm going to use a different color. Right? So they've given you a lot of information by just telling you that it's isosceles. Right? The sides will have equal angles across from them. So to find angle A up here, we will just go 180 minus 2 times 53. And this is one of the formulas I gave you when I gave you the notes there on page 181 or something like that. There was a blank page where we inserted formulas. So 180 minus 2 times the ones we know. So angle A is going to be 74 degrees. Right? That's this one right there. And so now it's an SAS, side angle side. So we're going to find BC, right? This is B and this is C. They want to know this side length here. What about this X? Well, you could have worked with this right triangle, but we know how to work with any triangles at this point. So we're just going to stick with the trig we learned, okay? So to find BC, we can call that, let's get used to that notation. We're talking about this stretch when you have two capitals like that, right? So that would be 20 squared plus 20 squared minus 2 times 20 times 20. And I'm running out of runway here, cosine of 74. Okay, so I'm using SAS here to help me come up with BC. And if you plug that in, you get this. You have 2407 as your length. Okay, Jordan, got you. Okay, so we found that side length here. Now, watch what it's saying. Classify triangle ABC, so that's this one, the big one on the outside, by angle measure and by side length. By angle measure, you know, right? Like if we come in here and just make the 74 appear here, 74 degrees, every single one of these angles is less than 90. So it's an acute, right? That's your choice there. And side length, we know that these two sides are the same. And this one obviously is different, right? We came up with 24. And so it's isosceles. It's an acute isosceles triangle. And watch this though. Did you have to find the side length here to say that it's an isosceles? The answer is no. You already, if this 53, if this 53 and that's 74, you know that this side length will be different. So there's not even an option of this being an equilateral triangle, because we know the only way for this to be an equilateral is if this had been 60, 60, and then you knew this would have been 62. So if all three are 60, that means that all three sides would have been the same. And then we would have concluded that it's an equilateral. But they asked us to solve for BC, so we did do what they asked us to do. On the next page, I'm going to answer it on this page though. Let's go on the, oh, there is no C. I got rid of it. Never mind. Even better. So let's keep going. This is where I got you to write down a whole bunch of stuff. Okay, good. There used to be a C portion there. We're going to go now, skip ahead a little bit and then come back. Let me just see here. We're going to go to 184. 184 should be a blank page in your booklets. So page 184, everybody. I'm going to ask you to, under this chart here, just make a line like this. We're going to use the top for something later on. Okay, so leave this blank up here, and then we're going to take some notes down here. So again, if you missed it at home, we're on page 184. Okay, there should be a blank page like this. So I'll ask you to classify the following triangles based on angle and side length. So I'm going to give you a whole bunch of examples to try. A, B, C. This is 50. This is 40. Okay, and then example B. Let's do those three first, and then I'll give you more. So what I would recommend on this, I would say find all angle measures. Find all angle measures to make it easier. This is just a thought here. That's what I would recommend. Sometimes you have to find the side length, but most of the time the angles will be enough. Okay. So I'm going to use a different color so that you know later on what was added after the fact, right? So you're given a triangle like this and you're like, there's no side length whatsoever. That's okay. We're going to find C, right? So angle C is going to be 180 minus 50 minus 40. Angle C ends up being 90 degrees. So this now actually, from turning one of these, you turn them into a square, right? That is a 90 degree. So right there, you have narrowed down based on angle measure. You know that, and that's normally the one you state first. It's a right, and then we have to figure out the other one by side length. So this is angle, bless you, and this is side. And so we know it's a right because it's a 90. And then here we have to determine, is it a scalene, is it isosceles, or is it equilateral? It's definitely not an equilateral. Isosceles, no, it's not, because there's no second angle that is the same. So this is a scalene. You know that all the angles are different, therefore all side lengths will be different as well. Okay, so we didn't know any side lengths per se, we didn't calculate it, but we can still make this, right? I will say here, all angles are different. And by that I mean have different measures, right? So there it is. Let's do B now. How would we do this one? Well, I know that these two sides are the same. Therefore, if there's a 40 across from this side, I know there's going to be a 40 here as well. Okay, so 40 and 40. Oh, now I have two angles. I can easily find the third one. So angle E is going to be 180 minus 2 times 40. Or if you want to go minus 40 minus 40, that's fine. Angle E is equal to 100 degrees. Okay, so now we know that these two sides are the same. This one will be different because the angle is different. Okay, so it's definitely not an equilateral. But we also know that this is an obtuse isosceles. We know that two sides are the same, and we use that information to help us find that third angle, which determined that this was an obtuse. Okay, and so that's how you do this. It's not terribly difficult. Okay, one more. We've got that this is 45, and these two sides are the same. Therefore, I can conclude that this must be 45. So it's always across the two sides. Therefore, H, I'll do that with a red pen here. H will be 180 minus 2 times 45. H happens to be 90 again. So now we can do one of those. And we can say that this is a right isosceles. Right isosceles. So you get 1 mark for each, by the way, on a test. So keep that in mind. I'll give you more here, 3 more underneath this. So I kind of make a line here. D. These diagrams are never drawn to scale, by the way. Make sure you copy this onto page 184, okay? The book doesn't have a lot of good examples in terms of classifying, but that's actually what the province is most interested in. I'm going to give you the reins now, okay? So you try to classify these 3 here. Let me just focus a bit. You try with the tools you've got, and there's not just one way. A lot of times there's more than one way to come up with the answer. So you give that a try. D, E, and F, classify them both. Show some work, okay? Maybe use a different color, or just use a pencil for now so you can erase it if you made a mistake. Okay, go. In the meantime, if you are here, okay, there are handouts right here. I don't know if you got them already, because I added a yellow one just today, so I don't know if you, but just come by one at a time and check what you need. It's for this unit, okay? Okay, so let's see what we've got here. So we've got triangle fun, right? There we need to do, we have two angles, 2 out of the 3, so that one should be fairly straightforward. So to find angle F, we would just go 180 minus 120 minus 30. Okay, so there we get that angle F is going to be equal to 30 degrees. Okay, that is something very unique. If you know that these two angles are 30, you know that the sides across those two angles are also going to be equal. Okay, so naming, if we were to name it, we know that this is an obtuse. That one was actually fairly simple. As soon as you have an obtuse angle, you know it's obtuse. And we know that these two side lengths are the same, so it's an isosceles. What about this one, Mr. Dirksen? How come you know that this isn't going to be the same all of a sudden? Well, it's 120, right? This is going to be different. So the only two sides that are equal are these two. Okay, so there it is. Over here, what can we do here? Well, careful here. We know that these two sides are the same. And so if you know that these two sides are the same, we know that the angles across from them will be the same also. Okay, because we know that this is at the very least is an isosceles triangle. At the very least, okay. Actually, we don't need to have those markings there. My bad. Just right, 1, 1, and 1 tells you that these are the same. We use these ticks for the side lengths. So let's find F. If we find F, we also find E, right? So I did this, I did that, I did this, and that. So angle F would be 180, right, minus the 60 divided by 2. Now you have to be careful. The top has to be done in brackets, okay? So angle F is going to be 120 divided by 2, which is 60 degrees. So angle E is also 60 because these two are the same. So this is 60, this is 60. So all three are 60, which guarantees you that this will be 2.5 inches also because all angles are the same, therefore all sides are the same as well. Therefore, this is an equilateral. You don't have to say acute because all equilateral triangles are always acute. There's no doubt about that. If you want to, I'm not going to mark it wrong. Okay, what about this one? This is a side, side, side. We know by looking at the side that this is scalene. Right? They're all different. But we need to find out this. We need to make sure this is, we know this part. So we have to find out angles. I would always recommend, and I told you this, when it's at SSS, you always find the biggest angle first. So let's go ahead and do that. Cosine, right, where we like that. No, I think I did 2 lines for you. Let's figure out that. This doesn't work out, does it? One second. I think I copied this wrong. Yes. This was supposed to be 2.2. Let me just double check. Yeah. My bad. This is supposed to be 2.2. Can you change that? 2.2. So we got to change this to 2.2. Otherwise, you're going to get an error. It's not going to work out. So change all the 1.2s to 2.2s. And then you get this. 12. That's more like it. So you've determined that this is an obtuse triangle now. So it was a little bit more work. Obtuse scalene because all sides are different. All right. Okay. So what I'm going to do is go back a little bit and tell you which questions to work on for the next 20 to 30 minutes. Okay. So make sure you write this down. So I'll leave it there for another couple of seconds. Why did we have to do this? To determine, because we're kind of suspecting that this is greater than 90. We now confirmed it. Don't just look at the diagram, and because that you could not have guessed. Okay, you can't just make that assumption. All right. Okay, if you're at home, let me see where I'm going to start. So 182, circle them, okay? Because I'm not going to get you to do all of them. So 4, so if you go to 182, page 182, okay? Circle question 4, so that means all of it. Circle 5, so 4 and 5 on 182. 6 is a bit of a challenge here, the area. I will just tell you the area is base times height divided by 2, okay? That's the area of a triangle. You can figure that out. And then I want you to do example 4. So basically everything on page 182, 183. Keep going. This is the last one. For now, 185. Go to 185. And I want you to do question 7, which 7 bleeds into the next page. There's a C on the other page, so make sure you get that, okay? So I'll write it down again here. Do page 182 to 183 and page 185, or was it 84? 185. Okay. So those pages, all of it, whatever you see on there. And just read carefully, okay? Read. And try your best to do what they're asking you to do.